Can you hear me okay?
All right. Yes, I can.
Okay, good. You would think with all the virtual events that we've all been doing, like I would have this audio video input thing down, but maybe I do, maybe I don't. So first of all, thank you to Don and Gordon. They did a really good job of setting the stage of what I'm going to focus on. For those of you who don't know me, my name is Melissa Palmer. I'm a VMware certified design expert, and I'm a senior technologist at Veeam Software in the product strategy group. I'm actually from New Jersey as well. I haven't been to a VMUG meeting in person in some time because, you know, kids got in the way and they always had something or somebody or whatever. Hopefully when we go back to in-person events, I'll be able to make it one of these days. And I want to kind of start by, if I can figure out how to use this, telling a little story. So I work at Veeam, obviously, and when people hear Veeam, they're kind of like, well, that's a backup company, but we're not necessarily going to talk about backup so much. We're going to talk about recovery. So we're going to talk a little bit about recovery in general, why it's so important. Some design considerations around recovery and things that we should be keeping in our minds as we kind of design for it, and then, you know, different types of recovery because not all recoveries are created equal. I do have a couple VME slides at the end that I'll probably blast through very fast because Gordon did an excellent job of talking about some of our V10 features that I'm going to talk about, but there's a couple things I want to hit for recovery in Veeam. But most of this is going to be about designing for recovery or recoverability, the VCDX way, in your environments. So let's go. So what do you mean it's not about backup, right? Veeam is a backup company, and I came to work for Veeam because of the awesome technology. And the way I kind of got into it a little bit more is I kind of knew of Veeam. I had used it here and there. But when I was working on my VCDX project, I got to the backup recovery BCDR section of my design, and I was basing it on a real customer I had worked with. I was SE at NetApp when I had worked with the customer, and at that point I was designing FlexPods for NetApp. And I looked at the solution that we had done for the customer, and I'm like, you know, I really don't want to use this, and I don't want to have to defend it in front of the VCDX panel because it's just not going to go well. So I took a look at Veeam, and I kind of re-architected everything with Veeam technologies. And while I was doing that, I came to realize that stuff was pretty cool at Veeam, and I really liked the way it worked, especially with NetApp. And when I did join Veeam, for those of you who know Rick Vanover in the VMware community, he actually hired me. I had met him at VMworld in 2017. Well, I'd known him for years, but we had talked about it. He had a position on his team. So when it opened up, he reached out. But I joined Veeam right at the perfect time to work with what at the time was their brand new disaster recovery product called Veeam Availability Orchestrator. Now it's version 3, and I've been with this product pretty much since the beta was at the end when I joined, all the way through to version 3 today. And that's, again, all about recovery, not necessarily backup. So once upon a time, a little bit more about me. I was a VMware administrator. I worked for Shearing Plow and Merck. You New Jerseyans probably know those two companies. And I always got paged for missed backups because it was a VM. And I'm like, I don't really care that the VM missed its backup. Go talk to like the server team, because it's just not my problem. And I never really thought much of it. Then I became a NetApp SE, and people just wanted the fastest backups ever. They said, you know, my backup window is however many hours, and my backups need to finish then. So I need some crazy storage system that's going to do this for me. And I was kind of like, oh, okay, you're telling me your requirement is your backups need to finish in X amount of time. I guess I can make sure you have enough throughput in your storage to do that. But I didn't really understand much of that. I was just trying to give my customer what they wanted. And then in 2012, I had a really big customer that was focusing on, you know, our backup windows, our backup windows, our backup windows. And, you know, I'm in kind of new at NetApp SE, new to being an SE in general, kind of new to storage. So I engaged someone a lot more senior than me. And I got probably some of the best advice when it comes to backup, replication, recovery, and all that good stuff I ever got in my career. Now, just a reminder of what was going on in 2012. It was vSphere 5.1 on that terrible Flash-based web client. That was what our vSphere interfaces looked like. I had to dig around the internet from one of those pictures. but you know, this guy said to me, it was very senior, he said, Melissa, it's not about backup, it's about recovery. And I was kind of like, well, but the customer's telling me that they need to back up in this crazy amount of time. He goes, no, backup means nothing if you can't recover. So pop quiz for all of you, why do we need backups? Anybody? Like, why do we need them? Why do we do it?
Insurance.
Insurance is a good one.
Keep the auditors off our backs.
The auditor, I knew someone was going to say that. Yeah, we need to audit, but at the end of the day, why do we need insurance? Why do we need auditors?
You need to recover your data.
Yes, thank you. We need to recover our data. We have no insurance policy if we can't actually recover it. And if we don't actually test that we can recover it, those auditors are going to be pretty angry when something actually happens, and that's not good. So it's all about recovery, believe it or not. And, you know, part of the life cycle of our data is recovery, but it starts with production, right? So all this weird stuff can happen in production, right? We could have a malicious actor, human error. Things just get really complicated and it's hard to deal with. And then we back it all up. But there's problems with backup too, right? The data just keeps growing and growing and growing. Operations can be manual. There's security problems these days. And then we have a DR site, right? Okay, we have a DR site, and maybe if we're lucky, we have decent hardware in our DR site, but maybe we don't, and there's budget constraints there. There's different types of environments. It might not be what we have in production. There's like 5 different million clouds these days that we might or not be using. And kind of the final stage, not necessarily final because this life cycle just keeps going and going, is recovery, right? So there's all of these problems when it comes to recovery. What if we have a tight RTO? What about those compliance regulations and those auditors come in and are like, hey, what's going on? What about just trying to come up with a DR plan in general? So there's lots of problems when it comes to protecting your data. And both Don and Gordon did a great job of talking about how to solve some of those. But today, again, I want to focus more on just the recovery portion of things. So why do we recover? And I have this funny picture right here of like a flaming server thing that just somehow has made it into my slide decks because I think it's funny. It's not in fact fine if your servers are literally on fire, but why do we need to recover, right? And there's so many different reasons. Fire, flood, alien invasion, zombie apocalypse, ransomware, accidental deletion, a malicious actor, a failed patch or upgrade, a hardware failure, a site level failure, right? There's all these different things that that can happen in our environment. And we need to be ready to respond to any of them. So let's talk a little bit about designing for recoverability, right? And recoverability is kind of a strange word. And you're like, Melissa, why are you saying this weird word? When you look at the VCDX blueprint and the VCDX process in general, we always talk about the 5 design qualities. And their availability, manageability, performance, recoverability, and security. They're all abilities for the most part. And I use them in this order, ANPR, this is how I remember them. And we're going to focus on recoverability today and talking about that. But availability ties into recoverability very closely. So we're going to start kind of talking about how the two go together, and then we're going to dive deeper into designing for recoverability and the things that we all need to be thinking about as infrastructure people, especially VMware infrastructure people, right? I have another pop quiz because I love my pop quizzes. How much downtime does an SLA of 99.9% allow? Anybody know off the top of their head? That's okay. I'll tell you. There's this website called uptime.is, and you go in there and you put in your however many 9s you want to do, and it will pop out all this stuff for you. And if you ever decide you want to do a VCDX, you better memorize like a list of 9s because you will be probably asked. But how much downtime does an SLA of 99.9% allow? And it depends on how you're looking at it, daily, weekly, monthly, yearly. But basically, on a yearly basis, it's 8 hours, 45 minutes, and 56 seconds of downtime. Right? So that means if I have an SLA of 99.9, which doesn't seem that high right? Because people were talking about 5 nines and stuff like that. It doesn't seem that high when you think 99.9, but here's what the numbers work out to be. And so how do we make sure we actually meet that SLA? It kind of comes down to a deeper dive into our recovery and specifically our timeline around recovery. So let's build this slide out. This is a slide I've been using, but changed a little bit for us. I'm just going to build it. Okay. So we're going to talk about things in the context of your last backup right now, but it could be your last backup, your last replica, your last replication job on your NetApp, whatever you want. So everything's good. We're chugging along. We're happy. Something happens. We have a disaster. The time between our last backup replica, replication job, whatever, the last good copy of our data we have, and our disaster is our RPO, right? So our RPO is basically the time between there. So we're going to say, okay, our RPO is 8 hours. Fine. Let's go with that. Then we have our RTO and our recovery time, right? So from the time we have a disaster, you know, some people use this metric called reaction time. I'm not thrilled about it, but I've seen it coming up more and more. So, okay, something happens to our environment. Do we declare a disaster? Is it actually a disaster? Do we need some time to say, we need to look closer at this before we start recovering, all that kind of stuff? Reaction time. And then from the time we decide, okay, we're recovering, to the time we've actually got some functionality back in our apps is our RTO, our recovery time objective. And then there's a difference, right? There's a difference between kind of being online enough to function, and then there's a difference between full time to recovery, right? And that means everything is running just as it was in production, we're at full capacity, all that good stuff. So work recovery time. All of those, right, combined. So if we look at our reaction time, RTO and WRT, work recovery time, is our maximum time down. How much time can we be down in our environment? And we're going to talk a little bit more about how we actually make those decisions and how, as an VMware person or IT person, you can make sure that the decisions are being made correctly, right? Because they can't be made in a vacuum. I can say, oh, I'm going to give my vSphere environment 3 nines and call it a day, right? There's got to be something behind that. So we're going to talk about that a little bit more too. All right, so we talked about SLA, our 3 nines, right? And our RPO. So 99.9, we talked about 8 hours and 46 minutes. Let's just call it 8 hours of unplanned downtime yearly. And that's the trick with an SLA. So whenever you're setting an internal SLA, or maybe you're outsourcing to a service provider, or you have a contract with a colo, it's always important to look at the contract, right? So 8 hours of unplanned downtime yearly if you don't want to violate that SLA. Now, that doesn't mean you can't have planned maintenance windows. Planned maintenance does not fall within your SLA. That's not counted, right? That's not going to violate things. But when you're negotiating those contracts, it's important to know what whoever you're negotiating with says counts towards and not towards the SLA. So they might say an SLA of 99.9, however, our SLA isn't valid on the weekend, right? It's not 24/7, 365. It's only business hours. So really got to watch those contracts. But the trick is, and how RPO and RTO work with SLA, and we'll mostly talk about RTO and RPO going forward here, is they have to fall within the SLA, right? So you can't have an SLA of 99.9, 3 nines, and have an RPO of 12 hours, because 12 hours is older than the data you need to have to meet your SLA. 8 hours, you can't exceed that 8 hour mark for not 3 nines, right? Same thing with like your RTO. You can't go beyond that 8 hour mark or you're not going to be within your SLA. So when you're doing a VCDX and you have people you're talking to about it and you send it to the review board, right? That's one of the first things that people are going to look at. Does your SLA match your RPO and RTO? Is your everything matching from a business perspective? And again, really pay attention to that SLA definition. Maybe it's just 4 hours of maintenance a month. Maybe it doesn't it doesn't come into effect on weekends, holidays, etc. Anytime you're signing anything with an SLA, pay attention to the definition. I have seen many, many people get burned by not paying attention to that. So I built out a little chart here, and if you are really interested in VCDX in general, or just kind of some of the design principles behind it, Renee Van Bedham, he's number 133, and I'm number 236, so that gives you an idea of how much longer I came after Renee. He has an excellent blog series, especially on how availability and recoverability relate. And again, it's important to keep everything within your SLA when you're designing, right? If your RPO exceeds your SLA, you violated it. If your RTO exceeds your SLA, you're going to violate it, right? So don't violate your SLA, don't violate your RPO, don't violate your RTO. Not only important for becoming a VCDX, important in general design and providing value to your business, right? If you blow your SLA that you're providing to your organization, not going to be happy, right? We're going to have issues coming down from the top if we actually have an event that we need to recover from. So once again, and I am like hammering RPO and RTO, but they're important concepts when we talk about recoverability. The RPO is the point we recover to. Basically, it's how much data loss, right? How many hours of data can I lose? 8 hours, 2 hours, 3 hours. And the RTO is the time it takes to recover. How long are we down without service, right? How long before I can get basic services restored? And these numbers don't necessarily match, right? You might have an RPO of 2 hours. I can't lose more than 2 hours of data, but it's okay if it takes me 12 hours to recover. It all kind of comes back to what the business needs. And where do the numbers come from and why do we care? We care because for us to design, operate and maintain our environments properly, we need to understand the drivers, and we need to make sure that these numbers were actually created correctly, right? That someone just didn't pick out of the sky, I want 5 nines in my vSphere environment, and they have no data backing that up. So we need to understand as operators and administrators where these numbers come from. We need to care because they're going to impact how we do things in our environment, how we design our architect our environment. Other things to keep in mind your work recovery time and your maximum time down as well. You don't want that MTD to ever go past your SLA, or you've blown your SLA because you've been down too low. Why are we here? Why are we here talking today? We love VMware technology. I myself have been working with VMware for years and years and years. I think it's the coolest thing ever. But at the end of the day, we all exist in our roles, in our jobs, in our IT organizations to solve business problems, right? We are there to enable problems to be solved, new products to be created, and making sure that our infrastructure is available for those application teams and those business organizations to do that. Downtime costs in many different ways, right? It depends on what kind of company you are. If you are a company that takes online reservations for a hotel or something like that, and you're down, you might lose money in a couple different ways, right? You might lose to your competition. They might go stay at a different hotel chain because they couldn't book the reservation when they wanted to. And once they do that, they're probably not going to come back to you. It also costs in reputation. If somebody goes to your website, and I keep on using all these website technology examples, but there's lots of other organizations this applies to too. If somebody goes to use a service that you provide and it's not available, it's going to cost you money in lost revenue, and it's going to cost you money long-term in reputation. So as an ISV architect, you need to know how much money. If I have an application owner telling me, hey, I have the most important application in the organization, and it's going to cost me $20 an hour if I'm down, and I need 5 nines, that should raise some alarm bells, right? Who cares about $20 an hour? Sure, there's reputation costs too, but $20 an hour? If you have someone come to you and say, hey, I'm an application owner, and my application needs 5 nines because we will lose $100 million an hour. Yeah, that's something to pay attention to, right? And all of this comes out of something called a business impact analysis. That is where all of the key stakeholders need to get in a room, your C-levels, your app owners, your IT folks, and hash it out. They need to, your finance folks too, right? Because there's always a dollar component. Everybody needs to get together and hash it out and say, how much does this application cost me if I'm down? What is the revenue I have? And how do I break that down into how much money I'll lose? And then an even harder decision needs to be made. if I'm going to lose $100 million an hour, how much downtime is acceptable to me? And they might say no downtime, right? And you're going to have to fundamentally architect that application, that infrastructure in a very different way than if they said they could be down for 8 hours. So the results of the business impact analysis will give you the RPO and the RTO. And from there, then we can kind of go on and design our infrastructure accordingly, design our applications accordingly. But until we have an understanding of how much downtime can we take, how much data can we lose, how long can we be out of service, and what that's going to cost, it's really hard for us to do our jobs. So now a couple of tips, since we've hammered all that kind of, I don't know, people find RTO and RTO really boring, but I think they're important. So now just some more kind of practical tips for designing with recoverability in mind. Be wary of speeds and feeds, right? We all like speeds and feeds, better, faster, stronger. Why do we like them? I mean, it's kind of fun to architect an environment that is super fast and I recover my whole data center in an hour. That's awesome. That's a great opportunity to hone your design skills, and it's just plain fun. But again, why are we doing this? What is the requirement? The business needs to come back to us and say, here's our RPO and here's our RTO, and we are required to make these because of these business reasons. We're not required to make an 8-hour RPO and a 12-hour RTO because the sky is blue today. Again, we have decided that our business cannot sustain a loss of more than X amount of money. This loss is quantified in X amount of dollars per hour. Therefore, we cannot have more than 4 hours of downtime and lose 4 hours of data or what have you. So as much as people say, hey, I want 5 nines and I want an RTO of like an hour or 5 minutes or 0 RPO, 0 RTO, that's fun, but it's not requirements. So again, we always got to go back to our business drivers behind why we're doing anything. And then designing for recoverability, right? It impacts our design. How do we actually meet this RPO and RTO? And it depends on so many factors. It depends on our vSphere hosts, right? Storage arrays, networking, what backup software we're using, our backup repositories, the people involved, and even design constraints, right? They could tell you, hey, we need 5 nines, but you have to use all the hardware we have in-house. We can't buy anything new. So you need to rework things to give us our 5 nines availability. And all of these items, right, all of these, they have capacity limits. So we have to have an understanding of our environment and how we're going to be impacted by designing these new applications. Do we even have space for them? You can tell me all you want that I can't buy anything new, but if I physically don't have the space on my storage array for a new application, or if you're telling me my RPO is, I don't know, less than an hour, so I decide I need to replicate my storage, if there's not space in the other storage array for me, that's a risk, right? That's a risk that you as an architect need to bring back to your stakeholders. The risk is I can't actually have enough capacity and it's not going to work, right? So it's our job to kind of take a look at our requirements in our organization, right? Why do we need these RTOs and RPOs? How do we meet them? Take a look at the infrastructure we have or the infrastructure we're going to purchase, and also understand any design constraints. And people can be a huge design constraint, right? If I have unlimited funds, but my people have a core skill set, and I can buy any hardware I want, I might want to look at the hardware that I already have, right? I might want to look at the same server storage I have already and see, can I meet my requirements buying more of what I have versus having to go train new people, because that's going to have a cost too, especially when it comes to a restore scenario. If I have a team that is used to recovering with Veeam all day and all night, do I really want to change that? If I have a team that's used to using Cisco UCS hardware, do I really want to change that? Up to you, and it's something to consider in the design process. So here's another interesting thing, right? All recovery is not equal. We're talking about RTOs and RPOs and all that good stuff, but they're not all equal. Even if they have the same RPO and RTO, that doesn't mean you're going to recover the same way. So what are some of the things that we need to think about in our environment, right? When we're designing, why are you restoring or recovering? And these are just a list of some scenarios. One server broke, something got deleted, one application broke. That stuff's actually pretty easy, right? But what happens if many servers broke? What happens if just like so many things got deleted? What if the whole file share just got nuked? How am I going to recover that? What if many applications broke, right? What if it's more than just one thing? What if it's just a ton of them? And come on, my personal favorite, everybody knows this. What if zombies came and ate my data center and I have to recover my whole data center? How we're going to actually do that is different in every case. And I kind of have a line in the sand here. Because when it comes to one something, generally it's a matter of someone logging into whatever backup software you're using, doing a restore, that type of thing. But when we have to scale up, that's when we need to start looking at things like orchestration and automation to help us recover. The next thing to think of is, where are you restoring from? And I have like asterisks all over here because I'm going to make some real general terms here. Backups are cheaper but can be slower to recover from. And we talk about Veeam has instant VM recovery, which is a lot faster than restoring fully, so that you can get some speed there. But in general, backups are a little slower to recover from than a replica, right? Fast recovery, everything's sitting there and I just, power on the VM. But it's more expensive because I need to have compute network and storage already on there. And what kind of replication am I doing, right? We have Veeam replicas, but we can do storage-based replication too, right? Again, replicated storage, fast recovery, not as expensive necessarily as a full replica in some places. Maybe the best of both worlds, up to you. I have a big NetApp background. I will snap mirror all day and all night. But all this stuff impact RPO and RTO, right? So where am I restoring from? If I have a 12-hour RPO, a 12-hour RTO, yeah, restoring from backups is fine. If I have a 5-minute RTO, restoring from backups going to take too long. So it's important to keep RPO and RTO in mind as you decide how you're going to handle each type of restore. This is another fun one. Where are you restoring to, right? Are you going to your Site 2 data center or a DR site? You go in a colo, you have a nice little contract in place with them, they have an SLA. What about a service provider? Maybe you just want to go DR as a service and get out of the game. And what about the cloud? Restore to the cloud, that's a thing now, right? We can do that. And it ties back to your business impact analysis, right? Have you verified that you can meet RTOs in all of these cases, right? Or perhaps you, with your organization and your skill set, you can meet your RTO fastest if you go to the cloud versus your own data center, because there's limitations. It really depends. But there are options on where you're restoring to. And it really ties back to people again, right? Where are your people the most skilled? They're going to be the ones doing the restores. And what level of restore are we doing? Are we doing a full data center restore, or are we just restoring an app or two? Once again, things to keep in mind as you're trying to figure out how to restore everything in your environment. So the capacity problem. Yeah, capacity is always almost going to be a problem for you. Almost every case. You need to make sure you have capacity for a restore or failover or what have you, right? Especially if you're keeping everything on-prem. If you're going to a second data center, you need to make sure you have enough compute capacity, network capacity, storage capacity, backup reco capacity. And yeah, by the way, the cloud's not a charity. So you could say, hey, we're just going to go to the cloud and have at it. We want to get out of the game. It's not going to be free. Really great use case I had actually with a customer. We were re-architecting and rebuilding brand new vSphere environments. 2 data centers, active type thing going on. Let's just call them Site A and Site B. Site A was done first because they wanted to work out all the kinks of the implementation because they were changing their storage arrays as well, right? So they wanted to go through the process once before they did it again. Makes sense, right? Why am I going to do 2 things in parallel and maybe mess up everything? I'm going to go through once, get through the kinks. When I do Site 2, it's going to fly. We didn't really have many issues in Site 1, and Site 2 went fine too, but there was a period of time where we didn't have the same capacity in both sites. We had this brand new vSphere environment in Site 1. We were starting to put production workloads on it, but we had no place to recover in Site 2, right? We just had the old stuff there. So what did we do? We took a close look and said, okay, of the stuff we're moving to the new environment, what is the most critical? And we made space. Then we said, okay, our plan now is in the event of a DR, we're going to power off dev and test in site 2, and we're going to use that to recover our new infrastructure in site 1. If we run out of space, depending on how long it takes site 2 to get online, then we're going to look at DR as a service solutions temporarily with some managed service providers to get us the space we need. We'll send our backups to a service provider temporarily, and should we need to recover, we'll just recover there. Did it cost more money? It did, but it met our requirements. And to that customer, it was important to be able to maintain their RPOs and RTOs throughout this new infrastructure process. So Greg Creative, like the creative solution we came up with was like, hey, do we really need dev and test in a disaster? No, because everybody's going to be recovering production. They're not going to have time to do any dev or test work. Let's just turn it all off. And that was one way we got around it. But capacity is always going to be a problem. Double, triple check your capacity. Capacity from a perspective of what is the new stuff I'm designing? How much capacity is that going to take? And how much capacity do I have, right? Am I building like for like in 2 data centers? Am I in the scenario I just talked about where we have an older data center that we're using for recovery? It matters. Now show me the money, right? Here's a warehouse of 5-year-old hardware. Have fun and build your DR environment. Not necessarily the best thing ever. So the question now becomes, how do I justify the spend on DR? I can't tell you how many customers I worked with where, oh, well, the NetApp's off support. We're going to send it to the DR site to die and hope that it works when we power things on. Same thing with the vSphere host. Yeah, we're going to send them to the DR site because we're not going to use them anyway and just hope that everything works. Hoping that everything works isn't a good business plan. But again, it's really hard to justify spend on DR resources. That's why we need to tie things back to RTO, RPO, and our business impact analysis and be really solid. If we have a solid understanding of a business impact analysis, we can tell a business how much it's going to cost. So sure, you want to use that 5-year-old hardware, it costs you $1 million an hour for downtime. Are you sure you want to rely on the stuff that has no support contracts and is really slow to run that application? Chances are people are going to look twice. Another use case is to prove that you can use more than just DR with your DR resources, right? Leverage those DR resources. Don't let them just sit there idle. Do things like DR tests, patch testing, training, penetration testing. Use it as a copy of your production environment. And there's ways we can do that in an automated manner with Veeam. Probably one of the most other important things is who is doing the recovery, right? Let's say we have a great plan, we have great infrastructure. Who's going to do it, right? Is it our Veeam admins? I'm just going to use Veeam as an example because that's where I work. Is it our Veeam admins? Is it our vSphere admins? Like, who's going to do this? How many VMs are in scope for each of these types of DR plans? What's their RTOs and RPOs? And can we test it? And how often have we tested it, right? So we have this great plan on paper. Everything looks good. Got to remember about the people. What if there's a hurricane, right? And you want everybody in the data center to recover and people can't get there? Are you able to draft other departments to help you? This might also be a use case where an automated tool that'll just go and do everything for you is really beneficial. Now I just want to quickly browse over recovery, the Veeam way. I have a couple slides. Some of them Gordon did a great job covering, but what it really boils down to is recovery is about meeting recovery objectives at a VM or application level, right? If a VM fails, I want to be able to recover it. If a whole app fails, I want to be able to recover it. And at scale with ease. If my whole data center goes down, I want to recover that too. With Veeam backup and replication version 10, there are 83 different ways to recover things, which is just crazy. I love this diagram. We update it every single release. So new in version 10 that we talked about, right? Network shares, all different restore options for network shares. General options, this is kind of your core Veeam backup and replication functionality. Veeam Enterprise Manager, that's kind of like your self-service portal for some of your administrators. We can actually integrate into vSphere RBAC and let your vSphere people just go and recover all day and all night. But the fact is with Veeam is there are a ton of different ways to recover things. Gordon talked about enhanced instant VM recovery. That's really why I kind of had that asterisk next to restore from backup, because while it can be slow, we can do lots of things at Veeam to make it a lot faster, especially for those important applications. Another enhancement was, hey, I want to recover a ton of VMs at once in the event of a disaster. That makes it really easy to do. recover an individual disk. My disk is corrupt. Do I really want to install, recover a whole VM even instantly? No, don't bother. Just recover the disk you need. Basically, recover anything you want to VMware vSphere with Veeam, and I mean physical servers, VMs, cloud VMs, migrate stuff back and forth. Anything you want to put into vSphere, Veeam can help with, right? I like to use agent-based backups as like a cheating P2V. I just take an agent backup and I restore it into vSphere. It's easy to do P2V. Likewise with cloud VMs, we have integration with major cloud platforms where you can send VMs to the cloud, decide it worked better on vSphere, and bring it back no problem. And then when it comes to large-scale DR, and this is one of my products, I actually specialize in Veeam Availability Orchestrator, right? It's all about automating and orchestrating the failover of Veeam replicas, Veeam backups, and now NetApp ONTAP snapshots. You can prove that you're ready to fail over at any time. It makes it really easy to do DR testing in an automated fashion. You can go schedule your DR test to run wherever. And we generate a ton of documentation, right? So you don't have to spend all that time writing that DR plan anymore. Really cool piece of software. If anybody wants to actually talk about, site level DR, app level DR, reach out to me offline and I'm happy to have a discussion. And here's our little cheat sheet for what you should keep in mind for designing for recovery, right? Know your RTOs and RPOs and where they came from, really important. Understand your business, right? Understand what the company does, right? I actually, when I started at Cheering Plow, they did this cool thing where they kind of put you through like a pharmaceutical boot camp and taught you the drug discovery and development process. So that was a really interesting perspective to have going into my career as a VMware administrator, right? Actually understanding what the business did, that was really interesting. Have different plans for different types of failures, right? How I recover a single VM, different than how I'm gonna recover a whole data center, but make sure I have plans for everything. And most importantly, once we have everything mapped out, test it regularly, update it as needed. Maybe you changed a piece of software, maybe you changed the VMs in an application, but it's important to kind of stay on top of recovery as much as possible. So that was kind of your designing for recovery bootcamp, and I managed to stay mostly in time. So if anybody has any questions, I am happy to answer them. After I have a sip of water.
Any questions? Feel free to unmute yourself and ask questions.